Hello everyone. In this video, we can solve few examples of the Fourier series. This is one of the important topic in the engineering mathematics. First is applying the Fourier series of f of x is equals to e power x in the interval minus pi to plus pi. The function is given as a periodic function. So take down the given function f of x is equals to e power x, which is defined for minus pi less than x less than pi. So here how the period is computed. The period is equals to the difference between the upper limit and lower limit. The upper limit is here. Pi is the upper limit and the lower limit is minus pi. If we take the difference of two, we'll get pi minus of minus pi, which is equals to 2 pi. So the period is 2 pi. So in the previous video, we defined the Fourier series, and the Fourier series is defined as f of x is equals to a naught by 2 plus summation n runs from 1 to infinity a n into cos nx plus summation n runs from 1 to infinity b n into sin nx, where we need to compute the a naught, a n, and b n. So what is the a naught? So where a naught is given by the formula 1 by pi, integration runs from over the given interval. So here we can write once more the given function. What is the given function? F of x equals to e power x from minus pi less than x less than pi. So the integral becomes from minus pi to pi, that is in the given interval, into f of x into dx. So which is equals to 1 by pi, integration runs from minus pi to pi, e power x into dx. So and we know that integration of e power x into dx is e power x itself, and integrating we will get 1 by pi e power x integration is e power x, limits runs from minus pi to pi. So 1 by pi, replace x by the upper limit value. The upper limit is plus pi, the lower limit is minus pi. We'll get upper limit value minus e power minus pi, which is equals to e power pi minus e power minus pi divided by pi. This is the value of a naught, and since in the formula a naught by 2 is there, we can compute that a naught by 2 is e power pi minus e power minus pi by 2 pi. This is the value of a naught by 2. So we got the a naught by 2. Next is we need to compute the value of an and bn, that can be used with the that can be computed with the formulas, that is the by using Euler formulas. So what are the Euler formulas to find the Euler coefficient for the cos, sorry, for the an? So that is given by an is equals to 1 by pi, integration runs from minus pi to pi, f of x into cos nx into dx. So and substituting f of x, we can write integration runs from 1 by pi, runs from limits runs from minus pi to pi. F of x is e power x into cos nx into dx. So here the integration is there. It is a product of two functions. One function is e power x, other one is cos nx. We can't apply the integration by parts because the differentiation of either e power x or cos nx never vanish. Means if the differentiation of either f of x or cos nx will not approaches to 0. So we will use the formula, the standard integration of e power ax into cos bx plus c is equals to e power ax by a square plus b square into a cos bx plus b sin bx plus some constant c, that is the constants whatever it is there. Sorry, this is for only e power x into cos bx, where c is the integrating constant. Using this formula, so here on on comparing the exponential term. So here in the power term it is there 1, and in the case of bx it is there n here. So therefore the value of a and b are, so a is equals to 1 and b is equals to n. Then the value becomes 1 by pi e power x divided by a square, that is 1 square, plus n square into a cos bx 1 cos nx plus b value is n, so n sin nx, limits runs from minus pi to pi. Now replace the x by upper limit 1 by n square plus 1 is a constant, we can take it out. So replace x by upper limit, so means e power pi cos n pi plus n sin n pi minus replace x by lower limit, that is minus pi, will get e power minus pi cos n pi minus n sin n pi. So here it is important to note that sin nx n pi value will goes to 0 for any values of n, because in here n takes only integers, and cos n pi, so there are two values, one is the sin n pi equal to 0 and cos n pi is equals to minus 1 whole per n. And substituting values, we will get 1 by pi 1 divided by n square plus 1 into, so in both the terms cos n pi is there here, here also cos n pi is there, we can take it outside and we can replace by its value minus 1 per n. We'll get e power pi minus e power minus pi. So therefore the value of an is minus 1 per n e power pi minus e power minus pi divided by pi into n square plus 1. This is the value of an. So next is we need to compute the value of bn. So we know the formula. Find the bn. The formula is given by bn is equals to 1 by pi. Integration runs from minus pi to pi f of x into sin nx into dx, and substituting the given value of f of x. What is the f of x? So the f of x is given that as f of x is equals to e power x. So on substituting that, we'll get e power x into sin nx into dx. Now again we will use the standard result. So that is the integration of e power ax into sin bx into dx is equals to e power ax by a square plus b square into a sin bx minus b cos bx. Using this, we can write this as, again I'm comparing. So here the value of a is equals to 1 and b is equals to n, that is with the standard form. So it will become 1 by pi e power x by, we can write a square plus b square as n square plus 1 into a sin bx, that is a is 1 into sin nx is sin nx minus b cos bx, n is the b is the n, so n times cos nx, limits runs from minus pi to plus pi. Now replace x by upper limit and x by lower limit minus pi. 1 by pi n square plus 1 e power pi into, so now just we are replacing x by pi, wherever x is there replace its value by pi. Upper limit is completed, minus lower limit, replace x by minus pi, so e power minus pi, so minus sin n pi minus n times cos n pi. So here the first term, this is for the upper limit, so means replace x by pi, and this is the lower limit, so that is the replace x by minus pi. So further we know that sin n pi value gives to 0, so sin n pi and sin n pi will goes to 0, and cos n pi value, we know that its value is minus 1 whole power n, so this value will also goes to minus 1 whole power n. So and n is there together, we can take n common, n into, already here 1 minus is there, here minus 1 power n is there. By using laws of indices, we can write minus 1 power n plus 1 divided by pi into n square plus 1 into e power pi minus e power minus pi. So this is the value of bn. So we got all the values of an and bn and a naught. So now we can list out to what are all the values we got. So from the computations we got the value of a naught by 2 as e power pi minus e power minus pi by 2 pi, and we got an as minus 1 whole power n into e power pi minus e power minus pi divided by pi into n square plus 1. That is what we computed just now. And then bit later we computed bn value is n times minus 1 whole power n plus 1 into e power pi minus e power minus pi divided by pi into n square plus 1. So with these values and the Fourier series expansion, we can write the Fourier series of the given function. What is that? So f of x is equals to a naught by 2, so plus summation n runs from 1 to infinity a n into cos nx plus summation n runs from 1 to infinity bn into sin nx. Replace x by a naught. Sorry, replace a naught by 2 as by whatever the value we got. Then we'll get e power pi minus e power minus pi divided by 2 pi plus summation n runs from 1 to infinity a n value, replace its value, that is minus 1 per n. So we are going to replace by this value e power pi minus e power minus pi divided by pi times n square plus 1 into cos nx plus summation n runs from 1 to infinity n times minus 1 whole power n plus 1 into e power pi minus e power minus pi divided by pi into n square plus 1 into sin nx. So this is the required Fourier series for the given function. Is the required Fourier series for the given function.